I'm trying to do this, and it was an idea that I took from Jared and from the book because it's something that may be more familiar to you. I'm going to create a card game, right? You're all familiar with cards, right? Sometime or the other, when maybe you were kids or even now, I don't know. You've all seen a deck of cards, right? So we'll try to create a card game. Now, before I create a card game, I have to create an entity called deck of cards because you play a game with deck of cards. Before I create the deck of cards, I have to learn how to create a card because cards together make a deck of cards. So I have to know how to create a card entity. Then I'll kind of create a collection of these 52 cards in the right. I exactly know how much of each and what suits and whatever. I'll create a deck of cards, and then with deck of cards, I'll create a game, right? So those are my steps. So my first step is to create a card. How do you define a card and what can a card do? Now, a card can do a lot on its own. When it comes in a deck of cards, it is more useful, but otherwise a card usually can't do much of its own. But how do I look? So if I bring a card in front of you, which is visual, all of you can see it, what are the properties or attributes that help define a card, a playing card? What can you think? Suit. I hear suit.
Number or name.
Number? So are we talking about which number? Which number are we talking about? I don't see a number here. Come out of it. What number? Yeah, there is a number, but come out. Which number?
It'd be 11, but represented.
Exactly. So for king, it will be 11, 12, 13. Right? Every card has a number. Sometimes numbers are clear, 4, but sometimes numbers are not clear. So I need something else also. So there is a value. So there is a suit. We all know there are 4 suits in a card. We have spades, we have diamonds, we have hearts, and we have clubs. You all know that, right? Anybody who's not familiar with cards at all. I'm not too good, but at least I know this. Every card will have a value. Now, sometimes this value may be clear, 4, but sometimes this value may not be clear. Kind of define it ourselves, right? So there is a value. So we'll go 2 to 14, right? Because we have 2, 3, 4, and ace is 14. Some people go 1 to 13, whatever you decide. In some games, A is taken to be 1. Okay, so games can be different. 3, what else? So that means something is missing because this card doesn't have a value, but every card has something else. A face, right? So every card has a suit. Every card has a face name. That name is a string. 2, 3, 4, 5, 6, jack, queen, king, and ace. These are its names, strings, right? And then every card has a value, starting from 2 to 14. Those are the 3 attributes of a card, nothing else. That's how you define a card. Those are the characteristics of a card. Anything else that you need to create a card? Okay. You don't need color because color is determined by the suit. Because color we don't have to, because color automatically depends upon the suit. Suit is important. So those are the 3 attributes. That's it. That's how you think of a class definition. What do I need to define that class? And 2, what can I do with that entity? Now, as I said, as a card sitting alone, it's kind of useless. You know what I mean? Like, you don't do anything with cards. But I'll make it useful when I join 52 of these. And what do I have? A deck of cards. So a deck is nothing but a collection of cards. So instead of collection of strings or collection of numbers, I can also collect card objects. Now, what do you do with a deck of cards? So there should be some methods with deck of cards. What do you do? Shuffle. So there should be a method to shuffle. What else do you do with a deck of cards? Draw could be one, or deal them out, right? So when you play a game, you deal them out. Draw will depend upon the type of game you're saying, yeah, but you could draw a card. Sometimes in some games you draw a card, right? You do that. So those will become the methods of my deck of cards. What do you do with a deck of cards is the methods. So you don't do anything with a card as per se, like you don't eat it, you don't sleep on it, like you don't do anything with the card. But as soon as I say deck of cards, I had answers. I said shuffle. I heard shuffle. That's what you do. You shuffle. That's what can I do with the card, deck of cards. And then somebody said draw. Ryan said draw. Makes sense. And then William said deal, which is more common because we usually deal cards, right? Those are the methods. So a deck of cards, instance variable, how do I look? Collection of cards. That's how I look. And then what can I do? I can shuffle, I can deal, I can draw. Have that, then we'll write a game. And then game will work with the deck of cards. Usually you play with a deck of cards, but sometimes you play with 2 deck of cards, sometimes with 3 deck of cards. And then you can form a game and so on. So start looking for a game, and one student only does one type of game, and of course it is not to be copied from the internet. So think of a simple game that you can play with a deck of cards. I'll write one. I'll do one for you. I'm not too good at all, but Jarrett showed me how to play it or taught me how to play it, so I know normal card game. But you can do many card games. Memory game is something I play a lot. Solitaire is something you can play with a deck of cards. So these games I'm aware of. So you can think of any simple game you like with a deck of cards. Because maybe 2 weeks from now I say build a card game for you. Right? But it doesn't come from anywhere. It doesn't come from the internet or nothing. So you don't copy code anywhere. You think of anything simple. Anything simple. But I need to see that you can use a deck of cards. Okay? So let's start. So the first aim is to write a class to define a card. Then step number 2, to write a class that defines a deck of cards. And then 3, to write an application that plays a game. Because remember, game is an application because it is using a deck of cards. Okay? Okay, let's draw the class chart or the class diagram. Let's not call it chart. It's called class diagram in UML of your class because you will be expected to do it in the exam too. So the name of the class comes here. Please use Pascal naming conventions for the name of the class. Letter of every word is capitalized. Okay. Then come the attributes of the card, and then come the methods of the card. Okay, so this is the name. Pascal name, Pascal case, instance variables, camel case, and then the methods. And constructors are methods. They're just special methods, but they're methods. Camel case. Okay, so we've decided that we will need private. 3 private instance variables. So minus stands for private. And those instance variables are, we'll call them face name. Type is string. Face value. Type is int. 2 to 14. Right? And then the suit, which is again a string. Those are my 3 instance variables. Right? Now come the methods of the card. I said I can't do anything with the card, but definitely I need the constructor. Right? If the default one, yes, one, or if you want something else. So when you create a card, whenever you create a card, you will need all these 3 values. So let's make a constructor. It really doesn't matter how you write them, whether you want to go like this or whatever you like. So you need a string for the suit, you need a string for the face thing, you need an int for the value. Returns is nothing. That's your constructor. So just say the types, as long as you understand what they are, they're okay. I mean, I don't have to mention their names. So string, string, and int, write it as int, string, string, write it as string, int, string, whatever you like. However you write it is how you use it. Then I need the getters and the setters. So I'll have 2 for one, 2 for the other, 2 for the third, and then I'll always write my favorite 2 string method. Right? So you say a set, you say a get. We'll start with face name. I'm just going short here because I don't have space. Okay, you don't go short, please. Set first name will take a string. Oops. And will return void. Signatures of the method are written here. Right? Plus stands for public. Then comes the name. Then comes the parameter list in which you just mention the type. You don't have to mention any names. You could string S if you like, but you don't have to, and then the return type. Get face name. Does not take anything, returns a string. Then you say your set face value, takes an int, returns void. Get the face name, face value, takes nothing, returns an integer. Then you have your set suit, takes a string, returns void. And then, oops, 1, 2, 3, 4, 5, 6. Get your suit, takes no parameters and returns a string. And lastly, the 2 string method, takes nothing and returns string. My class diagram is complete. Now all I'll do is I'll take that class diagram, excuse me, take that class diagram and change it into code. Right? So once you have decided these are the attributes of my class, these are the methods of my class, kind of list them out like this, and you will know, you have to know how to draw class diagrams. It's a part of your learning Java, so you should know how. It could be a little different. People use different. Some programmers don't write this at all. I prefer to. There is nothing wrong. It's not my convention. It is a followed convention of putting minus for privates and plus for publics, and the types and the return types everywhere. I've just done what I feel is something that is complete. So plus minus tells me it's access specifiers. The parameter tells me what kind of parameters it takes and what number, and the return types tells me what it takes. So this is a class diagram for card. Your aim is to take this class diagram, please come back then we'll start the card and then we'll do the deck of cards. Okay, so take a break here and we'll then start a new package and go from there. Oh, today is Thursday, okay. It's not Wednesday today.
Are these supposed to be in our assignments?
If I ask you to make a class diagram, yes, they are supposed to be. If not, then it's fine.
Both instances of trouble. It's a lockdown. Which you can get away. Otherwise you can't. You have to pass. If you have. You have no other result. Otherwise, hide whatever.
Change the like the phone rotates at the speed. Advance the
And you pass some of the course mandatory as well. So just that.
Oh, it's so colorful. What are you using? Which ID?
Sublime.
It's a
Sublime.
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 Okay. Oh my God, so colorful, right? So deck. Also, we call it card because this is a card and not a deck, right?
Okay, yeah.
Because then deck kind of seems you're talking about a collection. And the instance variables comes. Oh, okay, so you have to change the class name.
No, no,
That
will
is
be
right. That is not
This.
right. Yeah. Yeah, okay, so rate is the value. Okay, so it's not 0 to 13, we'll go 2 to 14, right? 0 is not. So if you
Oh,
want to
because
go,
of the ace?
yeah, and it starts with 2, not with 0, not with 1.
So one?
Yeah, assuming, yeah. And we can do something in suit also. Actually, we should do all validation everywhere. The suits are only 4 and the face names are only 14, right? And I was looking it up in arrays, yeah, I could do a binary search. I was looking it up.
I was thinking of using
Mhm.
the pattern to establish it can only be the actual names of.
Yeah, so it's,
String
yeah, so there are 4
characters.
string variables. Spades, hearts, whatever. But face names are 14, 2, 3, 4. So I was thinking if we could put it in an array and do it. I was trying out. Actually. Yeah, that's what we'll do.
I just showed her my
Oh,
thing. It's the first time I've ever gotten one 90.
oh, is it? Oh, that's good. So you get a 19 or is that when you get
90 is my average. For last semester, and this one it's above 80. I think you get on the team list. He knew the suit would assign a random
Yeah,
number,
so we'll
and
throw an
he
exception.
assigned the numbers to specific.
So we'll say else, we'll throw an exception and let it not happen. The suit is spades, whatever, else we'll throw an exception. I was thinking of doing it in a better way than I did it first, so I was looking it up. I'll discuss it in class.
Class ends at 4:30 or 4:50.
Class?
Yeah.
The class finishes at 3:50.
I was thinking it was in the setup, it randomly generates a number between 1 and 4. And then in your main, you can then assign.
Yeah, but remember, we will be using the card class from the deck of cards, so we will be passing the value. Right? We'll always, a deck of cards will always have 13 of each suit. So we can't do randomness. We have to exactly create 13 of each. What we can do here is check that the value that is coming to it is in the right range. Though we don't have to, because deck of cards will take care of it. But when you write a class, you kind of make it also self-independent.
The only issue with Sublime is that I have to go through my terminal to execute.
To compile also and execute also?
Compile, no. Execute.
Do you have a Mac machine? Oh. But there should be, for Mac, there is Eclipse for Macs.
I think so.
Yeah, for Netflix also, there should be. I
I've
can't
been
handle
using this one and
it's so colorful, right? It would distract me.
Sublime.
That's why I hadn't heard of it. Maybe it's only for Mac or something, is it?
No.
No?
For Windows.
For Windows too? I never used it. I've never gone back to using an on or a command line. But when I learned Java, we did it on command line, right? But we didn't even have something to type it in. I used text pad. It was long back, like it was somewhere. Java came in 90s, 1990 or 91. So we used text pad to type it in, and we used to compile it on command line. But once I came to IDs, I've never gone back.
Wouldn't it have to be greater than or equal to 1? Otherwise.
No, we are going 2 to 14, right? 2 and then till 14. Ace is 14.
Oh, okay. So
If you wanted to go, then you would go 1 to 13. If that's what you want to do. Wrong class. Okay, so let's start. Let's start to create our card game, the card class first. You already have a, okay. So you already have the class diagram here. All I did was I created a project and I gave it a name, card name Thursdays, to keep my sections separate. Okay, you don't have to call it that. You can call it whatever you like. Card game is not a bad name for your project because that's what your ultimate aim is. So we'll start with creating the card class first, right? And then from the card class, we'll go to the deck of cards. And then from the deck of cards, we'll go to the application because we need a deck of cards to play a game. Now, while I do it, I'll ask for your ideas because there is something that I was pondering since yesterday, how to do it, and maybe idea. So I'm going to create a new class. I'll keep the card game for my constructor, or for my application, sorry. So let's call it card. Like you can call it whatever you like. Again, the aim is to give good names, descriptive names, so that it is easy to remember. So please put your Java comments at the head of the class. So this class describes or defines whatever you would like to say. Remember, every card object, we've already decided what we need as instance variables. So start filling it in, okay? Oops. So as I said, you can use since if you like, you can use version, whatever makes sense to you. So since is usually with the JDK versions that they use, JDK 1. Oh, it's June 1 today. I'm looking for May and I can't see a 5. Okay, and then version is just. So that's what it basically does. It describes a card object. Okay. Okay, so let's write our instance variables. Keep in mind, all instance variables will be private unless they have to be public for a reason. So we've decided that these are the 3 private variables we need. So I'll kind of stick with the names here, then it's easy, but it depends on you, whatever you would like to do. So we need a face name, we need a suit, and we need a face value. So whatever order, really doesn't matter. That's your first one. Again, the convention is just to write it on different lines, but I usually do that. I mean, but some people like to do it on the same line if they're the same type. I leave it to you. Conventions we don't forget, right? We will follow conventions like rules. Names of classes, Pascal name, names of instance variables, bless you, name of instance variables, camel case convention. Don't forget, conventions are a must in Java. Almost like a rule, as I said. So these are my instance variables. All my variables will be private. If I need any constants, which I will, I'll add them here. Again, constants usually are created at the class level, so they are static just because constants don't change. And since they don't change, why not just create a copy and let every object use it? Okay, that's the idea behind it. So again, we make constants private if you have, because you only have to use it within class definition. So I will need some constants, and if you kind of think about it, the face value to 14. Now, if you want it to be 1 to 13, as I said, some games use the A says 1. You can, and then you will have to change your range. But again, as I said, whatever card game you create, if you need the 1 to 13, that's what you will use. I'm going 2 to 14 because that's what usually it is. Okay, so I'm going to create 2 private static final constants of type int. Now to give names, you can choose whatever you like. You can call it the minimum value. You can call it minimum face value, whatever it is, but give it a good name. And again, don't be lazy. You can just call it minimum value if you like, if the face is too big. So we'll give it 2, and we'll create another private static final variable. Another practice that is common is that an enumerated class is created in which all the constants go, and then that class, since it is in the same package, it can be used by all classes. So if there are a lot of constants in your in your application, right? You need a lot of constants. So I'm writing some classes and I want a lot of constants. You can always you can create an enumerated class also. It's just like a class with, of course, some differences, but you can create an enumerated constants in them. So I'll kind of do this for now, and then as and when I need it, or a little more maturity in the semester, we'll do it. So those are my, so remember, these are instance variables, but these are not instance variables. Instance variables means they will be present in each instance. Therefore, they're called instance variables. These are constants. These are basically class constants because it has static, right? Notice, so they belong to the class. So these are just constants. You can say class constants. That means every object can use them, but every object doesn't have a copy of it in it. Instance variables, every object has a copy of it inside it. It belongs. Every instance, every object has a different value for it. May or may not, but has its own place for it. Whereas static constants or static variables are at one place in memory, and all objects can use it. Okay, now we'll write our normal constructors. If we need the empty one, we will, but usually a card is never created empty. A card is always created with a face name, a face value, and a suit. Empty constructor doesn't make a lot of sense. Null, null, null doesn't make a sense. I mean, if you're creating a card, you better create it with the 3 parameters. Okay, so this constructor or this method, whatever you would like to say, constructs a card object. So with the constructor, there is not much to write, because that's all it does, right? It creates a card object. Of course, with a certain suit and so on. So we definitely know we need params. So you can start putting those params. So your param is suit, that's your first one. And if you want, you can say a string. Then we need a param for the face name. The sequence doesn't matter, but usually we try to give it the same sequence as in parameter list. It's kind of easy to remember. You can give them different names. And your third param, in no particular sequence, is face value. And it is an int. The string and int are again not very necessary. I've seen it being used at some places and not at the others. Those are your 3 params, right? Those are only 3, and I have to set all 3 parameters when I create a card. So this class does not need the default constructor. So as I said, how many constructors are needed, which ones, what will they do? You look at what you're creating. When you create a card object, you don't want to have a blank card object. Have you ever seen a blank card object? No. It will always have a suit, it will always have a face value, and it will always have a face name. Okay? Okay, so having said that, constructors are always public, have no return type, have the same name as the name of the class, and take or may not take any parameters. For us, they do. So you can go in the same sequence as you've written them. Your second one is your string. You can give them different names if you like, or the same names if you don't want to think of different names. As you put your closing bracket, I would make a habit of just saying the end of constructor or something, so that you know that's the end of constructor. And almost a rule, we will always call the set methods from our constructor, because all validations, anything that needs to be done, we'll do it at one place. So let's set the suit, which we haven't yet written, but that's okay, we will. And let it complain. We'll set the face name. And we'll set the face value. Names of methods also follow camel case convention. The red squiggly you can ignore for now, because all it is saying is these methods are not available. Right? That's all it is saying. So to kind of save ourselves some time, we can kind of get this set and get methods. So you can get all your for your variables, right? Don't get them for your constants. Doesn't make sense at all. So you This is the suit. And Eclipse and also NetBeans does point out your spelling mistakes. So please see that you don't make any spelling mistake in your comments. These are comments that the general public will see. People who use your class will see them. So see, they are neat, clean, clear, with no spelling errors. Okay, so the second one, the setting. Now here, this method will set the suit of the card. If valid, not after validating it, we'll say if valid. So that means if it is not valid, we are going to throw an exception. So you can add another one here. It's called add throws. Oops. I forget that you can't use spacebar. Okay, so this is kind of in the opposite manner to set the suit to set. Okay. Okay. Now the throws is a new annotation you're seeing, but all throws does it. It tells you whether this method will throw an exception. What is an exception? An exception is just an object. I mean, everything is an object in OOPS languages, right? So basically an exception is an object which is thrown. Those are its reserved words, throws and throw, which is thrown when there is some kind of invalidation in your input. Because Java works on the rule or the principle of called design by contract. It says, the set method says, if you give me a string and it is one of hearts, spades, clubs, and diamonds, I'll set it. Else, you didn't keep your contract. Here have an exception object. It's an error. I won't go forward. The set method won't work. So the design by contract says, keep your side of contract and I'll do my work. If you don't keep your side of contract, forget about it. I'm not doing anything. So that's called design by contract. So throws basically says what I'm going to throw is I'll complete it afterwards. So now this one, once we write it, it will make more sense. Now this one is saying take a string from the user and set the suit to the particular suit. But we all know that cards can have only 4 types of suits. We can have spades, diamonds, clubs, and there's nothing else. But a string could be anything. Like I could pass Anju to it. I'm creating an invalid object. I'm creating an object with an invalid suit called Anju. How is that possible? It is not. So we will validate the string being passed to us. Now there are a few ways of doing it. I'll show you one way because this is smaller. There are only 4 values to check. But I have another something else in mind, which I would like to discuss with you guys if you have some input. So I'm going to say, check if the suit is valid. And how do you check? How do you check? How do you compare a string input suit example? How do you compare it with any of the 4 values? Have you heard of a method or do you know of an operator that allows you to compare 2 string values? So I want to check, are you spades? Are you diamonds? Are you this? If yes, either of this, you're okay. Else I'll throw an error. We can use a switch. Okay, but in switch, what will you say? Either one of these, and else in the default or whatever, you will throw an exception. You can do that. Perfect. One switch. Anything else? An if. Perfect. And in if, what is the method in the string class that allows you to compare 2 strings? Is there a method or do I use the equal operator? Compare string is one. Yeah, but okay, not bad. Anything else? Are you aware of? Okay, so if I want to do this, so switch definitely will work. I want to just bring out the method in the string class because I want to point out something. Okay, that's why I'll use that. But again, switch is perfectly fine. And again, if you are not aware, switch, you wouldn't have been able to use switch before 1.5, I think, because you couldn't use switch for string variables, but now you can. So it's okay. Okay, now is this syntactically right and logically right? I'll just start with spades just because I remember it. And then we'll say or. So in any of the cases, you can start writing your if statements one by one. It's a long one, but since there are 4 values and I want to show you something, and tell me where am I going wrong. Can I compare strings with this? Syntactically, it is not incorrect, but logically it is incorrect. Why? You know of the equal operator, right? The 2 equals is the equal operator. You compare two numbers and it works perfectly fine. What happens when I use the 2 equals in comparing two string values or variables? I'm comparing the variable suit with the value spades. What do you think?
Exact strings versus spelling changes.
Okay, that's one idea, but not entirely correct. Those two methods are equals and equals ignore case. What does the equal operator do in when I compare strings? No idea?
Compare memory locations.
Exactly, it compares memory locations. Saved somewhere. Do you recollect that a value box, int, which are data types like ints and floats and doubles, are value boxes. The value resides inside the memory location in the box. Whereas any object, and of course we know that string is an object, has a memory address where your actual value resides. So it's kind of pointing to this. So value boxes are different from reference boxes. Objects are reference boxes. They have the address where your value is residing, whereas a value box is the value is residing inside. So when I use the equal to in comparing two string variables or a string variable with a string value, I'm actually comparing the addresses. I'm comparing what's inside it. So what am I comparing? The addresses, because what's inside those boxes? Address. So you are kind of asking, does the string suit have the same memory location? Is it pointing to the same memory location that spades is pointing to? Where spades is not pointing to it, but it has a memory location. That's not what you want. You want to compare the contents. So syntactically, equal is not wrong, but it has a different meaning. The different meaning is that now you're not comparing the contents of the string, you're comparing the contents of the boxes which have addresses, because they're reference boxes. So to compare two strings, which is what you want to do here, you use the method. So you go dot, suit is your string variable, and you use the method equals. Now notice, I am seeing two methods here. I'm seeing a method called equals, and I'm seeing a method called equals ignore case. That's what Rick was saying. Those are the two methods. The equals ignore case is case insensitive. Doesn't matter. Case doesn't matter. So as long as it is called spades, exactly. Like you're equal to in your exact match, right? That's so. As long as the spellings are same, case does not matter. So I would definitely like to use ignore case. So it doesn't matter whether you call it with spades with a capital S, with a capital D, or whatever, but it's spades as long as it is spades. So equals is only used when you want to make your comparison case sensitive. When you want to make it case insensitive, please go with equals ignore case. So choose this and then compare it with suits or with spades, and now complete this. I'll kind of go to the next line, and we can just kind of copy this. Copy all four and kind of write it. And what was it? Shift Alt F. Okay, there. And of course, we'll have to change it. So we are missing, oops. And we are missing this last. No, so change. So this is spades, diamonds, hearts, and what's the fourth one? Clubs. Thank you. Oops, clubs. So be careful that for string comparison, the method to be used is equals ignore case or equals, depending upon whether you want to make a case sensitive or a case insensitive set. Do not use equal. It won't give you any syntax errors, but logically you will have wrong answers. So this is one way of doing it, which is writing an if, which looks complicated. The other way of doing it is the switch statement, which is perfectly fine. You can write all four values together, do whatever you want to do with it, and then default, which will be much neater. But the aim of using this was bringing your attention to equals ignore case. That was my main aim. That's all I wanted to do. The third way could be, and which I was thinking, because though there are only four values, it's not a big deal, but I've not been able to find 100% solution for it, for the simple reason that that search is not case insensitive. So there are different searching algorithms. There is a sequential search and there is a binary search. And actually in arrays, there is a class called arrays in Java class library, and maybe it's still open because I was looking at it before I came. Yeah, there are binary searches. So I could put my 4 strings in a string array, and I could do a binary search on it and say, are you there? Are you there? Binary search is just quicker than sequential search. Sequential means it asks the first one. No, not you, second. So it goes in sequence searching for something. In binary search, it kind of divides the list into half. It has to be sorted. Looks in the first half and looks in the rest half. The problem with binary search that is coming up, which I was not able to solve just because in the morning, I just had 10 minutes. So is that it is case sensitive. So spades, exactly how I write it is how I can search for it. So if I can think of something, or maybe I change the string, whatever you give me, I change it all into lowercase and then look for it, then it will work. I can think of a solution. So instead of writing these 4 in like this, or even using a switch, I can create an array. In that array of strings, I can put spades, diamonds, hearts, and clubs, and then I can search for my string suit in that particular array, because there is a method available. Binary search is available. The only thing I have to remember is I have to sort it, and there are only 4 values. I can either just write them in sorted order, or there is a method to sort an array. So that's not the problem. The problem I am encountering is that it is doing a case sensitive search. So if I put these 4 in my array, then there is only these 4 that will be checked for. I can't check for spades for a capital S. So it's not case insensitive. So I was kind of still going through, as I said, and now that I talk to you, maybe when the user gives me the suit, like when he provides the string to me, I just convert it into all lowercase and then search for it. You see what I'm meaning? Take the suit from the user. Doesn't matter how he calls it, capital, small. I do a lowercase on it. Everything goes lowercase, and then I compare it with this array that has these 4 values. If it is present, good. If it is not present, we are okay. That will work. Right? Lowercase will work. That could be. I just thought of it out of the blue. I was thinking, is there a method? Is there a method? And now I'm thinking all I have to do is convert it into lowercase and do it. So let's do it with the face name. So I leave this here for you to see. You can always add a comment for yourself that switch is also a good way of doing it. But the arrays one will be the easiest. Okay. And if it is not, and where are we? If this. Okay. And if it is not, I'm going to throw an exception, right? How do you throw an exception? You use the reserved word throw, not throws. They're different, okay? Throw is different from throws. You use the reserved word throw. You throw an object of type exception. Exception is a defined class already in Java, which is inheriting from throwable, which is inheriting from language. We needn't go into details, but it is a class, and many exceptions have already been defined. Arithmetic exception. You see it, index out of range, illegal argument. These are all exceptions that are already defined. If you can use one of them, good. If you cannot, you can always define your own exception classes also. We'll do that when we come to the topic of exception, but I'm using them. So you could create an exception object if you like, or to be more kind of specific, I'll create an illegal argument exception. The advantage is the name. The name is more meaningful. What I'm saying is that your argument, this argument that you're giving me is illegal. Illegal in the sense something is wrong. You could use it an empty construct. You say, oh, why is it giving an error? Oh, it has gone. Okay, the semicolon was missing. Sometimes am I mistaken? No, I think it's exception from the language package. Could be from java.lang since it is not complaining. So I'm not going to bother. Or another thing, it is better that you give a message to that exception. So when that exception is thrown, and you get it printed on the screen, you want a good message. And you can say something like this. Suit value is invalid. You can say this. So now you will exactly know what happened, what went wrong. You can even show the valid values. You can say the valid values are, and you can show all the 4 values. The better the error message is, better is your program. Because the user says, oh, this is what has happened. So that's what you think. So for now, I'm just throwing it, right? So whenever you throw an exception, you will have to create an object of the exception. How do you create an object? New. What type of exception do I want to create? I want to create this type of exception. There are many exception classes, many. Some of them are common, and some of them you will hardly ever see or use, but there's so many. You could have only said exception, but the exception class is divided into 2. Runtime exceptions and errors, as they are called. God knows why they call them errors. But anyway, and the runtime exceptions, illegal argument is a type of runtime. We'll talk again. We'll go, when we do details, we'll do it. But what this is doing is, I'll show you how it works. If you try to give a suit that is not one of the 4 values, spades, diamonds, hearts, or clubs, it is going to throw this error message on the screen. That's what it will do. But I'll make it pretty. I'll have to make the error message pretty also, which I will in the application. Okay, so that's what it does. It takes care of it. So my set suit method is sophisticated in the sense it won't allow you to kind of use any type of string because it's not valid. The only 4 valid values will be checked. If those are valid, it will be set. If those are not valid, it will throw an exception. So when you have throws here, you can put here throws. What? It throws an illegal argument exception. Everybody, like every Java programmer knows what it means. And you'll find them in your Java API. See, if you open up something like any binary search, you will see at the end, doesn't say anything. But if it is throwing an exception, it will say at the end, here, see, here it says, throws an illegal argument exception if from index is greater than 2 index. And I'll do the same here. I'll say throws an exception if suit is invalid. Right? So when this is turned into Java documents, it will say throws illegal argument exception if suit is invalid. So remember, all Java documentation is being done so that you can create something like this. This is all being created through Java documentation. They're just parameters, the return statements, and the throws and sins. That's all it is. Okay? And you know how to do it. Do you remember to go to, where was it, run? And then generate Java doc. It will create. And param not found somewhere, it says where? Card.java at line number 25. 25. Oh, see, it was called V with the capital face value. So if you see errors, just kind of see what they are saying. So therefore the build failed. Okay. Oh, that was build. That's nothing to do with it. So once you have it, I'll just do it again so that I don't see any errors. And here they are. What are we doing? Card. See? Looks familiar? How it is kind of created a hierarchy for you. It has said it's a public class, extends, describes a card object. That's your description. I don't know why author is not coming. I still don't know. It does come in Eclipse, I remember. Then it says June 1, that is your sins. Then here are your constructors. I only have one. Here are your methods that you've written. And if you click on one of the methods, what we did, we was just write the set suit method. Here is your set suit. So it exactly looks like how it looks like in Java APIs. So they've all been, and notice there is my throws clause, there is my param, and this method will set the suit of the card if valid. So Java doc comments are a necessity in the code. You have to write them. You should. That's your main aim in this course, to learn how to write Java doc comments. And if you can't remember, always check. The Java API is full of them. Right? So they'll help you. Okay, having said that, let's come back here. The next value, let's write get and set suit has been done. I'll come to face name in a minute. I'll do the easy one first. Okay, so this is okay. So let's write here. So a short description, and don't say the face value here. I mean, we never say the name of the variable because nobody can see it. And that's the get face value method. Nothing much to be done here. Gets are easy. What about set face value? Any validation? This method sets the face value of the card. If valid. What are the valid values for face value, guys? What are the valid values? 2 to 14. Perfect. So we'll do an if statement. Here we don't do a switch, we do an if. So don't forget your at throws also, please, because it will do the same thing. So an illegal argument exception. All one word, it's the name of the class. If if what is it? Face value. If face value is less than 2 or greater than 40. What happened to my throws? There. Now let's write the if. So the valid value of your parameter face value is greater than or equal to, don't use 2 and 14s here, please, because let me see if I can use in my Java comments also, because we don't want to use any magic numbers. I had a minimum something, right? What was it called? Minimum. There it is, minimum face value. Why isn't it showing up here? Minimum face value. More is needed. Oh. There it is. No, there it is. Come on. Enter. Okay. If its value is greater than minimum face value and the short circuit and. The short circuit and in Java. Have you heard of just a single and also in Java? There is a single and, but this is used more commonly because it works better. What happens with a short circuit and is if you're comparing many conditions, condition 1 and condition 2 and condition 3 and condition 4, looks at condition 1, it is true. It says, oh, it is true and I have an and, I have to check the second one. But if it is false, your condition 1 is false, it says, the operator is and, my first condition is false, I don't even have to check the other ones. It is false. So it works smartly. Therefore, they're called short circuit. As soon as they know whether the compound condition is true or false, they stop working. Okay. So if your face value is greater than or equal to this and less than or equal to this, and it was called maximum something, right? Then you're okay. So again, if doesn't need it doesn't need a squiggly brackets, the curly brackets. So if you like it, sure, go ahead and write it. I mean, I don't want to stop you from it, but it is not required if it's a single statement. Else, let's again do the same illegal argument through exception and definitely put a better message. And notice how I'm going to use my constants in my message also. What have I said? If the face value lies between 2 and 14, I have not used 2 and 14 because I've already defined them as constants. Then use it. That's fine. Set it. Else throw this illegal and say, and now you can, I want to show you something. You can say face value is invalid. It must lie between. It just needs a string, right? So I'm still continuing. It must lie between. You can show the minimum face value. Show it here because it's a string. I'll have to go plus and the maximum face value. So when you see the error, you don't repeat. So notice how I'm using my constants even in my error messages. I don't use the and the 2 and 14 anywhere. And that's the beauty of what have I missed? Through illegal face value is invalid. It must lie between, oh, the plus. No, it still is showing squiggly. Face value is invalid. It must lie between plus, another plus. There, plus. Now we are okay. Right? Pluses are concatenating strings. So now it will say face value is invalid. It must lie between 2 and 40. So notice again, I haven't used my constants. I haven't used magic numbers. Everywhere, even in my checking, even in my messages, I've used my constants. And that's the beauty of named constants. They make sense and they're flexible. So instead of 2 to 14, if you want to go 1 to 30, just go and change them there and it will change everywhere. Now my only thing was, which I haven't tried before, is can I do it in my Java doc comments? I don't know. I've never used it here. So I don't know. I don't think it makes sense, but I won't know till I do it, right? So if I use, I had that constant. Let me see if I can use it here. I mean, if I can use it, then it's really good that I don't even have to bother changing my comments. I don't know. I have no idea. It doesn't look logical that it will replace it in comments. I mean, it's too much to expect, but since they are Java doc comments, I don't know. Of course, it will not replace it in journal comments, but I don't know if it does. So how will we know? We can run it. We can do a, let's save this. We can do a run and create it. Oh, doesn't like it. It says malformed HTML add throws. It doesn't like it. And I mean, it's not like there's nothing to execute. So you know what? Can't do much about it. I can't do much about it. That was asking too much. Anyway, so use your constants in all your executable statements. All executable statements, do not use the magic numbers 2 and 2. Use them as constants. In your if, in your switches, wherever you have to use. Okay? Okay, so that should work. And now the last one. And that's last one I'll use my, I forgot everything. This was of end of class. Is it end of class? No, it doesn't seem like, because I think I wrote end of class somewhere. That's what happens when you don't do it as you go on. No, there is nothing else. I thought I did. Oh, well, if there is no syntax error, that means I must be right. Now let's write the last one. The face name. So the get face name is okay. There is nothing I can do in the get face name. This method returns the face name. Return the face. No variable names in at returns, please. Just a normal English like comment. The set one is something I want to work on. So the array, we'll create an array in which we'll put 2, 3, 4, 5, 6, 7, 8, 9, whatever, till ace, right? And then we'll search for something in it instead of writing switch statements. The switch will also have 14 cases. The if will also have 14 cases. So maybe this is a better way, right? So I'm trying it. I'm almost positive it will work, but I didn't think of it till I came here in a minute. Okay, so let's start. Create a local array. Do I need to create a? I don't think I need every instance variable has to have it. Or you can create a static array. You can even do that. Anything that only belongs to the class. Let's do that. So that if I have to do with other things, I have it. Okay, so please create a static array. So go private, static, string array. And let's call it faces. You can call it whatever you like. All caps, since it is a constant array. It's an array, so please go this. And we'll put some values in it. I'm creating, and you can create it as final also. Nothing stops you because its values doesn't change, right? So you can create a final static array. Why static? Because it belongs to the class. Every object needn't have a copy of it. And why final? Because it's not required. Now you have two options. You can create a sorted array yourself because the search method I'm using works only on sorted arrays. The elements are already sorted. Or doesn't matter, just put them in the order 2, 3, 4, 5 and then sort it and use it. Both options are available. Okay, so let's go. Let's start. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, after 10, we don't even go 10. Sorry, we go 9 and then we go, what is it in cards? So we go 2, 3, 4, 5 till 9. We do have a 10. The 10 is logical. The jack, now the jack. Oh, the jack is a capital J, doesn't matter. We'll keep it small. And then comes queen. And then comes the king. And then comes the ace. Please notice I'm doing all lowercase. Please follow the lowercase with me because I'm going to only search for lowercase. Don't mix and match. Don't do that. Otherwise, it will be a lot of work. So what have I created here? I've created an array called faces that has all the face names, the allowable face names in a card, right? That's the face names in a card. You could have used the digit 2 or the digit and that comparison would have again created problems. Okay, now I'm going to try something. All I have to do logically is this. The name that you give me, the set face name that you provide the method, if it is in this set, in this array, it's okay, else it's not okay, right? So I have to search for it. If the search is successful, I find it, good. If I don't find it, then no. Now, to use the search method, because I had an idea that it was available, to use the search method, I went and used the one which was using objects. You have it for shorts, longs, everything. It's available for integers. It is available for everything. So I'll kind of, because I forget. And then I have to look for the sort method also. So let's see. So there should be a sort method, S-O-R-T, P-Q-R-S-T, L-M-N-O. Okay. So definitely I know there is a sort method. There is a sort method. So sort method works on an object, sorts the specified array of objects into ascending order according to the natural order. So there is a way to sort the array. There is the method. Notice it says sort returns void. So I'll sort my array and it is a static method. So arrays.sort. And then I will search for something in it, and that's search, S-E. I'll show you the search also. S-C-A. Search, S-C-A. Oh, it's called binary search. Okay. You could use sequential search, but why do mode? So we'll do a binary search, B. This way you can see two things. It's called binary search. And there are few options in binary search. You can binary search for in numbers and so on and so on. I'll use the one which does objects. So kind of see where it is. There it is, this one. I'll use this binary search. This binary search returns an int. And the valid int, if it is 0, 1, 2, 3, 4, whatever, it is giving you the position. Yes, it is present. If it is less than 0, it is not present. That's what it does. Okay. So sort returns void, but it just sorts the array. Binary search, why am I sorting? Binary search can only be applied to sorted arrays. That's how binary search works. The list should be sorted. So therefore, I need to sort it and then search for it. In the search, if I get back a -1, anything less than 0 I can write, but I know it's a -1 because I've tested it. Element was not found, else it was found. Okay, so let's try. So what am I doing? I've created an array. I've created an array in which I've put my 2, 3, 4, whatever. Now let's complete the code. I am almost positive it will work, but you don't know till you run it. So where is setting the set get? Okay, there you are. No, that's the face value. So up. There it is, set face name. Okay, so start here. What do you want to do? You want to check if the name that I have provided you is present in the list. So let me write a comment for you. If face name is valid. That's what you want to do. This face name that I've provided you is valid. And we've already said that we can use a method called binary search from the arrays class. The class is called arrays. The method is called binary search. There it is, right? Sorry, binary search. Method is called binary search. Which one do I want to use? Doesn't matter because I know the one I want to use. And what am I searching for? I'm searching in that array called faces, right? What am I searching for? The face name. So look at one thing at a time. You are doing a binary search on this faces. Why is it giving an? Oh, because it was all capital. Oops, sorry. It was a constant array there. So I'm doing a binary search. But before I do a binary search on faces, I have to sort it. How do I sort it? Arrays.sort. There it is. So sort it. It already put. It's very smart. Okay, there. Now let's look at it again. I'm saying search in my array. Before I use the array, I sort it. It's a requirement. Your array must be sorted. You could have written it in your sorted manner, but why put the brains? Why should we do it, right? So sort it. Look for face name in it. If the result you get is greater than or equal to 0, that means you found it. So set it. Okay, so now I think it will say include or something. What is it giving? Alt enter. Let's see. I'm sure it will say something like, no, invert if, convert to binary constant, flip this. Why? No, that's none of the opening bracket, closing bracket, opening bracket. No, not necessarily. Oh, you mean I have a wrong? No, I don't have wrong ones. Void type not allowed here. Oh, void type not allowed here. Binary search returns a integer value. All I'm doing is comparing with, oh, I think I know. Array sort. No, brackets are okay. Void type. Oh, it says void type not allowed here. Oh, because this is void. That's strange. How else will I sort? Sort. MNOPQRST.
Can you switch them around?
No, we have to sort first and then we have to search in it. PQRS. There it is, sort. So you can sort any kind of arrays. I was sorting the object one. Look for object. Where does it keep it back? Sorts the specified into ascending order. Okay, let's see where it puts it. Sorts the specified array of objects into ascending order according to the natural ordering. All elements in the array must implement and compare. All elements in the array must be mutually comparable. This sort is guaranteed to be stable. A array to be sorted throws an exception but sorts it. Doesn't have a return type, so why is it says it can take a void type is what it is saying. Okay, let's try something else then. Can I do this then? Can I simply say arrays dot sort my array of faces? Can I do this as a singular statement? That's what it doesn't like, the void type. But it is returning void. So the faces array gets sorted, and then once it gets sorted, still okay. So this is the problem here. Okay, it just doesn't like a void return type in the search, the binary search method. So I sorted it first, like I just sorted it. It sorts it and puts it in the same array, and then I use the array there. It just didn't like how I had used it inside. It said void type not. So I've sorted it. This will sort it. So you can say sort the array. Right, once you've sorted it, search for face name in it. Or in the list if you want to say, but these comments are for me and you, so they can be a little technical also. You know what I mean? Java documents we keep general, but here we make it okay. So now if that's the case, let's do this. So it is, if it is greater than or equal to 0, Shift Alt F. If it is greater than or equal to 0, that means we found it. Else we will throw an exception. Throw a legal exception, okay? Okay, so we can copy it if you like from somewhere. There it is. It just makes it little easy, okay? Control B. Okay, so what do we want to say here? Face name is not valid. I can show the values, the valid values from the array. I can print it out. The valid values are, but at least this message is also good enough. Now, what doesn't it like? Oh, there's an opening bracket here. I'm just trying to show you that it is not required to have an opening bracket. Shift Alt F. There it is. Okay, as soon as I do Shift Alt F, it puts the brackets back. But for your information, these curly brackets are not required if you only have a single statement. There, now let's see if this class works. Do we have any errors? No. There are no red squigglies. So notice how I have done it in a better way. I could have done the same thing in my suits also. I could have created an array and do it. But there I wanted to show you the strings method. Ultimately, once I've done it and it works, I will go back to using this. So notice what I've done. I took an array in which I kept all my face names. Right? And then I said, look for what you've given me. Search for this face name that you've given me. If you find it, that's what it says. Anything 0 or greater means you have found it. From 0 till 13. Why? Because I have 14 of them. Okay, so if you have a value 0 till 13, you found it. And if I found it, I kind of, I give it. Else I say, it is invalid. Hopefully it will work. And how will I test it? I'll put it in BlueJ and test it quickly. So at this point of time, I either write a tester and see if my class is working. That's my, I have to do it. Otherwise, how will I create a deck of cards? If my foundation is weak, how will I create a deck of cards? If this class works, I know my card is okay and I'll go to my deck of cards. Okay. So the easiest way is, now since I have BlueJ, and if you want to, you can use it too. It's not a big deal at all. You can download it right now and use it. I'm going to do a Control A and C here. Are we all okay? Are you all with me? Can I, oh, what do I see? I'm missing some bracket somewhere. I have a problem in set face value. That means I didn't. Okay, so it's coming from here. Where else it is coming from? Not before that? No. Did I just, I must have done something right now, right? So that was okay. But it's having a problem right here. Class interface. And so I've closed. I have an extra one somewhere. There, we are okay. No, we are still not okay. No, we are okay now. I had an extra bracket. And that's why I said always when you start a opening bracket, always put a closing bracket and put a comment with it, which I forget to do myself. And they're the most difficult to find because it's so difficult to look for curly brackets. Right, now what I can do for a minute, just so that all of you have it, I can do this for you very quickly. Insecure connection, God knows where that was. Okay. That way at least you have it and you're just not looking like, right? If you have it in your hands. So I'm going to put this unfinished. We haven't finished the whole thing, but it's Thursday today. And I'm going to put this in. Okay. I'm going to browse my computer and get it for you and put it for you. So courses, Intro to Java, Summer 2017, Thursday, Card Game Thursday, source. Okay, you have it on Blackboard, guys, if you want to pick it up. Okay, now I'm going to do this. I'm going to go to BlueJ. Doesn't really matter. I can create a class. I mean, I'm just checking it. I'm going to create a new class, call it card. Do an OK. Open the editor, Control AV. Do a compile. You have, oh, package statement. No. Because I didn't, it had a package statement when it came and it said, that's not what your package is. And I said, okay, remove it. Okay, let's compile it again. Interface enumerate. Now here it's saying the opposite here. My God. Okay, so you are this. You are this and you're this. There's something wrong. I have a, it says. In the after the, there it is, after the else. So that's this, see, it's matching it. That's for if. Oh, so I have an extra one. I thought I removed it before I moved it here. Okay, no, it's syntax errors. Didn't I just remove it when I'm okay here. See, I don't have any red squigglies here. How many do I have here? 2. That's strange. I thought I removed. There are 2 here and there are 2 there. Okay, whatever. So that's compiled. Okay, now let's test it. Right, and the only thing I have to test is basically my constructor. The rest is like my set methods, right? Okay, so let's create it. Let's try to create an object with suit as Anju, which of course should come up wrong. The string doesn't really matter because it's wrong. The first one will throw an error and the face value 2 is valid. So this should throw an exception and it throws an exception. That's how it will show in BlueJ. It will throw an exception. Okay, so that's one done. Now let's try to give it a valid value. Let's try to give it a valid value for suit. And I'll kind of go spades with a capital P, small. I'll kind of mix and match, okay? so that you know that ignores case is being ignored. So spades. Now let me try to give something that's wrong for face name. That's, and yes, so spades is correct, but I should get a problem with face name. And I get a problem with face name. Okay, let's go back now again. Now let's try to go and do two things right. Let's go spades. Let's go string face name. Let's go jack. Oh, I forgot something. Anyway, I'll go small jack. I forgot something. And then I'll go 1. No, 1 is invalid. 2. This card must get created. Spades, jack, and 2. Right, so it got created. So that's fine. But I forgot that if I put, oh, this was ignores equal case. I forgot here. So I forgot this. Remember I said I will, before I do it, I'll change it to all lowercase. And I forgot to do it. So before you do this, what's that method called? To lower? I think it's called to lower. Take your face name, because you may give it in something else, and say to, there it is, to lowercase. Convert it into lowercase before you search for it, because all my names in my array are lowercase letters. If you don't do this, it will throw an exception. You see why? Because it is searching, and the searching, as I told you, was case sensitive. I haven't yet copied this to BlueJ, so I'll show you that even if I give a right face name, it will give a problem. So I forgot to do that. I forgot to convert my face name to lowercase before I did a binary search on it. And I know it is case sensitive. I'll prove it. Let's prove it. That's, I think, what I saw. Okay, so come back to your here again. Let's try to create a new card. So we know spades works, because that works, I know, equals ignore case. For face name, please try to give a capital E in T for 3. Anything, just don't use all lowercase, and go 2 or 3. 3 will have 3. Okay, let's try. I get a syntax error. I get a runtime error. Why? Because binary search is case sensitive. Everything in my array was small. Now when I change it, now I have changed it. I've made it case insensitive. I change everything to lowercase before I search for it. So Control A and C, come back on BlueJ, open it, Control A and V, compile it. Okay, oh, sorry about that. Again, and go here, and do it here. And again, let's create. So we'll go spades. You can even actually save it that way. If you want to be neat, all your cards should have the same lowercase everything in it. Anytime you give me something, I'll change it to lowercase and save it. That way it's neater. Otherwise, you can have all combinations. I'll show you what combinations can occur. For example, I go S capital, P small, A capital, D E small, S capital. It will save it exactly like that. If I change it to all lowercase, it won't. Okay, now let's start. Now let's face name go with T capital for 3. We haven't checked face value, but I'm almost positive it will work, but we can check. See, when I inspect it, it kind of looks untidy, but I mean, you can always make it tidy by converting. So now it works. So no case matters in binary. So binary search is case sensitive. I have made it insensitive now. I changed everything to lowercase before comparing. Why to lowercase? Because my array was all lowercase. So it works. Right, it is working perfectly now. So the only one I think, okay. The only thing I didn't try was the invalid value, but I'm almost positive it will work. So we have hearts. We have a face value of jack. And for whatever reason, I give a face value of 15. And I should have a runtime error. So everything seems to be working. To make it tidy, the only thing you can do is, not you. The only thing you can do is before you save it, you can just say values are okay. You can just say face name dot, convert it into lowercase and save it. It just will make it neater. That's all. That's all it will do. Though how does it matter? Not much. So before saving, convert it into lowercase. For neatness purpose only, this is nothing to do with logical, like nothing logical. Then everything saves in lowercase. When I print it out, they will all look the same. They will all look the same, right? So do that in face name and also do that in suit. So where you are saving it, if everything is okay, just convert this also into lowercase. Similarly in suit here, convert it into lowercase before you save it. for neatness. So now I think you can always replace, now you know how to replace these 4 by using an array. Makes it easy, doesn't it? I mean, I don't have to use equals ignore case. I don't have to write switches. I don't have to do anything. I just have to use binary search. And again, this is the beauty of Java or any object-oriented languages. You have methods. All you know is how to use them. Found out that I knew it. There was a sort method. So sort it and then do a binary search on it. Believe it or not, as a student, we had to do this ourselves. We coded it because there were no object-oriented languages, right? It was just procedural language. So anytime we had to search or sort a list, we would write our own code. And if somebody else wanted it, the best they could do was copy our code, because it's not in a library where everybody can use it. The only thing that I want you to add to this class that is left is the toString method. So assuming this is my last bracket, I'll write my toString here, right? So please override your toString method. This method overrides the toString. Is it time? No, okay. People were starting to come outside. This method overrides the toString method. And what does it do? It returns a string representation, or that's what it does. So let's put an at return card information. And what do I want to return in the toString? Don't forget your at override. That way, if you make a mistake, it is caught. It is a public method. It is called, what does it return? A string. It's called toString, takes no parameters. And let's return, what do we want to say? This of this, this of this, this of this. So we'll say return face name, or get face name. Put a plus of and get your suit. Remember, everything will come small case, because I've converted everything into small. So it will say jack of spades, or it will say 1 of hearts, or it will say 5 of diamond, whatever. So that's what I'm returning. That's what a card's information is. You don't say, I mean, for jack, you don't say 11 of suits, you say jack of suits, right? So again, if you wanted it to be all caps, we could have created an all caps form. There is something called capitalize also. Anyway, so this should work. The toString should work too. So again, I'm going to do a Control S. Any mistakes? No. So now we already know that everything is working. The only thing I have to test is let's create a card. And I'll again give all kinds of S, P, capital A, D, E, S, and jack of all spellings, capital C, K, and then face value is 11. And now just test the toString method. There it is, jack of spades. I know the jack J is small, looks bad, but you know what I mean? Like, the logic is absolutely correct. And it's only a printing. I only have to return something. I can always capitalize my first word. If I can find how to do that, there must be some method. Take your string and just convert the first letter to capital of both, and I should be okay. Which is not a big deal, right? So my card class is ready at last. So you've seen different things. At the end of the day, when you do an assignment, not end of today, I mean at the end of the day means whenever you do an assignment, see that you use the best technique, right? So if string comparison with equals ignore is good enough, you're only doing 2 strings, then it's fine. 4 is not bad, but it's kind of, many, 4 of them. But if you're working with a large number of strings, like 14 of them, I would definitely not like to see either switch statements or if statements. I would like to see something that I have done. It's available. And binary search is not a must. You can go and look for sequential search also. But the use of binary search is, it's quick, it's very quick. And the one they were mentioning, we use merge. They said we use some, I don't know what they were mentioning, but they had said that the time was best to take the minimum time to search for something. And binary search is quicker than sequential search. To go through a list of 50 will take more time than, of course, if I have a binary search where it keeps breaking the list in half every time. It only searches in half the list. So I have a sorted list and I say search for 10. If it sees the middle number is 15, it definitely knows 10 is less than 15. It completely ignores searching in the upper half. That's why it's called binary search. Every time it breaks it into two. And every time it breaks it into two, one is completely discarded because it can be in this half, in this half, in this half. And therefore, binary searches are quicker. If there is a sequential search, you can use that, then you don't have to sort your other. But I'm not doing it. I'm just using a method, so why not? Okay? Okay, so having said that, card is now ready. Your next step is to now create your step 2. Your next class is deck of cards, right? So the card class is ready. It has taken care of all validation. You can't, even if you use it from outside, I mean, even if you don't create a deck of cards, which I will, and I will kind of validate my data there too before I go on. Even then, your card is perfect. Your class is perfect. So whatever you do, whatever you create, always see that your classes are 100% right. Everything is being tested. All instance variables before being set are tested. It's your job. Your card should not rely on who's going to use me. It should say whoever uses me, I must do my job. But any wrong values in your card, and that's all the card had. There was nothing else. The two-string method was like, it's nothing. You only had your getters and setters. And those were important. So notice how important setters are. Validation of input is done in the setters. And I didn't repeat it in my constructor. I didn't copy and paste. I called the set methods from the constructor, and the set method will do the job. So copying and paste is not the solution, guys. It is not. It's the most worst solution you can have. So write the code in one place and use it. Okay. All clear. Is it making sense? I don't know what blank faces mean or no. Okay, thank you. Okay, so if it is not, then as I said, you may just need more help and you have to look for help. From me, from Jared, from a student, from tutors in the library. Look, we are already in week 4. So if you're lost, something has to be done. Okay, so now let's create a new class. So where was I? Here, Thursday. So go to your source package or to your package and again create a new class. And we will call this deck of cards. Right? You could have called it anything. You can only call it deck also if you like, because deck is a deck of cards, but anything, like as long as you're using conventions and it is making sense. Anything else that I want? Project card game source packages package in the Thursday section. We are okay. And there it is. So remove this. Write a short description of the class. What does this do? This class describes or simulates. You're basically simulating a deck of cards. You will be able to shuffle it also. You'll be able to deal it also. And I don't know if you want to have draw, but if you need it in your game, sure. This class. So another word that you use in class description is simulates, because it's trying to copy something. You know what I mean? So describes or simulates a deck of playing cards. You can start saying playing cards if you want. So complete your author. Oops. And since and version, whatever you like. So add since is definitely coming up. So June 1. And version is coming up. So 1.2. Okay, now, what are the instance variables? What are the characteristics, or what is a deck of cards? What is a deck of cards? What does it need? What is it? What is a deck of cards? A collection, right? We need a collection. So what should I use? What kind of collections are you familiar with in the Java language? Arrays. We just did an arrays, right? And arrays has an advantage and some disadvantages. One advantage is it is of a fixed size, and that's what we want. Fixed size. Cards is only 52. So we need a fix. So arrays will work. And we did see some methods like sort and search with arrays that I can use. It's not a disadvantage, but array list in Java is also a collection which is dynamic in nature. That means it doesn't have a fixed size. Plus, this also has methods to add something in a deck of. There's a method called add. I don't have to worry about the index or anything. In arrays, you have to work with indices. First element is at position 0, second at 1, so on and so forth. So when you work with an arrays, you have to know the array name, of course, but you also have to have working with indices. Like it's a little more work than simply saying add. Add will automatically add it to an array list. It adds it at the end, but it will add. Right? I can always sort it. Advantage, I have the advantage in both. I can sort either. Right? I can do both. There is a sort method in the collections also for array list cards. So I have an array, which is perfectly, it will work perfectly fine because it has 52 cards and so on. But on the other hand, I have an array list, which is dynamic in nature. And because I'm going to shuffle them a lot and I'm going to deal them and so on, because I'm going to do a lot of these things, which is kind of manipulating it, it's just easy to use something that has already methods defined in it and I don't have to worry about it. So add and get and delete, and it's all present in array list. So I won't bother to use arrays because in array, I have to kind of manipulate my indices. So I'll use arrays for all that I did, like checking and all that, it's okay. But to work with deck of cards, I can use arrays and you're most welcome to do it if you want, but you will find that array list is much easier. So I'll go with arrays, right? What kind of elements are going in a deck of cards? Is it numbers? Is it strings? Card objects. This is an array list or an array or a collection of card objects, not of anything else. I'm collecting cards to make a deck of cards. So the instance variable that I will need is, I'm going to declare an array list of type card and call it deck. Oops, there. Of course, with array list, you will have to import java.util. And that's all. So this is how you declare an array list of cards, of card objects. Give it a name. I've called it deck. You give every variable a name. So I've called it deck. Right? So that's the name. What is the type? It's private because I've kind of said we'll keep our data hidden. And what is the type of my deck? My deck is not an int or a float or a double or a string. It is a collection of card objects. So if I wanted to use an array, I would use an array. If I wanted to use an array list, I would say array list. And in the angular brackets, you are saying what is the type of elements inside the array list. And those are cards. That's how you declare an array list of card objects. Now, this is just a declaration. You haven't asked for space in memory. You've just said, I will need a collection. But before you use it, you will have to call the constructor of the array list class to get the object. This is just saying that deck. If you say deck is an integer, we are okay. We automatically get space. We don't have to ask for space. If we say deck is a string, we don't have to say new deck, though it should be said, but because strings are so common, we don't say. But it is an object. We should be saying new string. But definitely here I have to say, give me a new array list. Now the new is not put in declarations. In Java, we don't say is equal to new right here. We put it in the constructor. Otherwise, deck is null. So we will have to say is equal to new. The practice is not to do it right here in the declaration. The practice is to do it in the constructor. So I'm going to write the constructor. And the first thing I will do in the constructor is, before I forget, because if I forget, then it's kind of, I can't use the deck at all. So the first thing I'll do in my deck of cards is, I'll say deck, please give me an array list. Call the constructor of the array list. You go new array list, opening, closing brackets. But since I have to say what are the elements I want to save in it, then you give the opening, closing brackets. Oh, there was a double C here. So don't forget that. If you forget this, then deck is null. It's an object, it is null. If you don't ask for space for it, it's null. You can't work with it. You can add anything to it. You can do anything with it. It does not exist. Null is undefined. It does not exist. So don't forget, that should be your first job in any constructor that you write when you're dealing with array list. Then you won't make a mistake. If you forget that, sometimes it's so tough, you won't even find what the problem is. Okay, so here, let's write our comments now. Okay, so what do we want to do? We want to, this method or this constructor creates a deck of playing cards. It will do more. That's not the only thing. Therefore, my description is a little more It doesn't have param, it doesn't have a return. It doesn't take any params. I don't need any params. Now, what else do I want to do? So my deck is ready, but it doesn't have anything in it. It's a, by default, for your information, when you say new array list card, I think by default you get 16 empty spaces. I can find out. It's not a big deal. Control A and C. Go to your BlueJ. BlueJ will show you. Create a new class called deck of cards. I think it's 16 empty spaces by default. Of course, you don't have to use all 16, but or you can ask for more. That's the beauty of array list. You can ask whatever you want. Okay, let's compile it. Oh, you've changed the package statement. Okay, so it's ready. See, notice how deck of cards is using a card, how this arrow comes up. This relationship is called has a relationship. Deck of cards has cards inside it. It has an array list of cards. This relationship that you see on BlueJ is called a has a relationship. Okay, now if I create an object of it, I want to show you what's inside it. See, there is an array list. If I inspect it, it has a size of 0. There is nothing inside it. There is a size of 0 for mod count. You can ignore for now. It has given me some data. The length is 0. Okay, so nothing comes. It's 0. I thought it by default gives you 16. Maybe I am wrong. I thought it should say 16. Okay, so that's its length, which says there is nothing inside. So that's what's got created. I mean, something is created. You have a deck. It is an array list, but has nothing inside. When you add, automatically its size will go up by 1. Add another one. It automatically goes up. It just goes up automatically as you need it. As you delete, it reduces the size. So it's easy to use. That's why I chose to use an array list instead of an array. Okay. Now, so it is there. I don't know. I still feel array list gives something to start with. I'll look it up in the Java API. Oops, only 4 minutes left. Okay, you know what? 4 minutes won't get me a lot. Okay, I can just ask you the question, but we'll have to do it next time. What's your next job once I have the array list? What should I do?
Find your arrays.
Find your?
Find your arrays.
Which arrays do I need? The ones for suits and whatever and whatever. Yes, define those arrays. And then do what? Definitely I'll need the arrays. Then do what? What's my next step? How do I create this deck of cards? I take 13 of each suit, give it face names from 2 to ace, right? 2 to ace, and the values from 2 to 14, and store it in the array list. That's my next job. So we will need arrays because we need these 4 values and so on. That's what we'll need. But then I'll have to create. And what should I use to create these fixed 13 values of each kind and create cards out of it? What data structure? What should I use? What construct have you learned to do some things?
String.
What construct have you used to do a job certain number of times? What do you use? A loop, a for loop. A for is better because it's so. Use a for loop to create the first 13 cards, a for loop to create the next 13 cards, a for loop to the next 13 and next 13, and then take all these and put it in the deck. So I need a loop, and I'll tell you, I mean, it won't come into your head out of the blue. I had to read it too, but the logic is this: 4 hearts, spades, clubs, and hearts, diamonds. Okay. So for each, so an outer loop which runs 4 times for each of the 4 suits, and within each suit, I will need another for loop that runs 13 times because I have to add 13 cards of each card into the deck of cards. So I need a nested for loop. The outer for loop will run 4 times for the 4 suits, and the inner loop will run 13 times each for these suits, in which I will myself put the values, the name of the suit, then the name of the face, which will go from 2 to ace, and then the value which will go from 2 to 4. I have to do this because that's how you create a deck of cards. So I will do a loop to create a deck of cards. So that loop may not come out of the blue in your mind, but it's not so tough. When I write it, you will have it. It's just a little bit of tricky. Okay. Having said that, we will do that next week. The only thing I want to test is, and you guys can of course leave, and if there's a class I will leave too. What was I stuck at? Oh, the array list. I still think an array list gives some elements. So I'll starting. Oh no, stop.